How to measure with the Hip Dysplasia Pro app. The first thing is to load one image from your photo library or capture a photo from X-rays photos of a patient. Next, you fill in the empty boxes according the patient's height in cm and weight in kg. In case the height or the weight of the patient is unknown, by simply entering the age, the built-in feature chooses the exact middle weight and middle height of the person, calculating the 50th percentile according to normal reference data population adjusted for gender and age. The empty boxes are filled automatically with the middle values, respectively. You can also edit one or other directly in case that a value is known. Next, you have to fill the calibration unit box in mm after finishing the calibration procedure. With the calibration procedure, you try to locate the center of a template, a known dimension in mm object in X-ray, for example a coin, by moving the transparent circular yellow template over the object, coin, trying to fit to a best fit circle to the contour of the coin circumference. Once you have found the best fit by clicking the point button, the center of the coin is marked C1. Next, a dynamic circle appears with a C1 center point marked over the screen. The radius of the circle is changed dynamically, and by moving the attached finger you try to find the best fit circle to the contour of the coin. Once you found the best fit, you press the point button and the subject, whole coin, is marked by the circle and the radius point, R2, appears. If the coin, for example, is 10 mm, you enter the number 10 in the unit box. Next, by clicking the button point, you mark 2 points, point S3, left, and point S4, right, over the lateral edge of the superior end plate of the S1 vertebra, sacral end plate. The yellow horizontal line S3-S4 is drawn. Next, by aiming the center of upper middle distance of pubic symphysis with the transparent circular template and clicking the button point, the point S5 is marked. An erected vertical reference line from S5 is drawn. Right side, the transparent circular template appears and you aim to locate the center first of the right femoral head by moving the template over the femoral head, trying to fit to a best fit circle to the contour of femoral head circumference. By clicking the point button, the center of the left femoral head is marked C6 point, and the corresponding radius of the femoral head by clicking the point button, R7 point, appears. Aiming with the transparent circular template to the lateral acetabular edge, you mark the lateral acetabular edge by pressing the point button, E8 point. Finally, you aim with the transparent circular template the deepest point of the roof of the acetabulum or the triaradiate cartilage, if it is still open, usually at the halfway of the acetabular width, and by clicking the button point, the A9 point is marked. The acetabulum arc starts drawing. By the same manner, you mark the V10 point, which is the lowest and most lateral point on the acetabular teardrop, and subsequently you mark the point where the lower contour of the head intersects the posterior-inferior acetabular margin, point D11. Finally, you mark the site of insertion of the hip abductors on the greater trochanter, point T12. Left side. Without to recalibrate, you start the same procedure from the left side by marking the center of the left femoral head C13. R14, and as mentioned above, with the same order you mark the rest of the points at the left side as follows: E15 lateral acetabular margin of acetabulum, A16 deepest point of the roof the acetabulum or the triaradiate cartilage, V17 acetabular teardrop, D18 intersection of femoral head at the posterior-inferior acetabular margin, T19 insertion of the hip abductors on the greater trochanter. In quick view, you have to choose sequentially and manually the following certain anatomical landmarks, points, which are shown below with the correct order. Calibration procedure. C1 center of a known dimension object, R2 dynamic cycle radius of the known dimension object, for example 10 mm, enter 10 in unit box. S3 lateral edge of the superior end plate of the S1 vertebra, left, S4 lateral edge of the superior end plate of the S1 vertebra, right. S5 center of upper middle distance of pubic symphysis, right side. C6 femoral head center, R7 dynamic cycle radius of femoral head, E8 lateral acetabular margin of acetabulum, A9 deepest point of the acetabulum or the triaradiate cartilage, V10 the acetabular teardrop, D11 femoral head intersection at the posterior-inferior acetabular margin, T12 insertion of the hip abductors on the greater trochanter, left side. C13 femoral head center, R14 dynamic cycle radius of femoral head, E15 lateral acetabular margin of acetabulum, A16 deepest point of the acetabulum or the triaradiate cartilage, V17 acetabular teardrop, D18 femoral head intersection at the posterior-inferior acetabular margin, T19 insertion of the hip abductors on the greater trochanter. The powerful undo feature gives the user the freedom to make corrections without resetting the whole procedure. Simply by clicking the undo button, the measurement returns to last chosen point or state, and you are ready to choose the same point again, without resetting the whole measurement and starting again from the beginning. Moreover, the sides are independent, thus the user can measure first any side he wants. A complete report with all detailed calculations and measurements can be extracted and saved in a text file with the Save button. In quick view, the following indexes and angles are being calculated and printed on screen by the app. RG5. Load R exerted at the weight-bearing F0 weight-bearing area of hip joint surface. PG5 compressive stress, P, at the weight-bearing F0 hip value, HV, calculated after 5 years of age. Acetabular Center Margin angle, ACM, Acetabular Index AI, after 7 years of age. The acetabular index of the weight-bearing zone, A, is calculated instead. Center, edge angle, CE, Acetabular Depth-Width Ratio, ADR, femoral head extrusion index or Reimer Index, RI, Congruity Index, CI, Sharps angle, SAE, Tonnis grade of dislocation, TG, Congruence Index, CG. Please see tutorial videos at the developer's website. The software is a Class II medical device in the FDA. All information received from the software output must be clinically reviewed regarding its plausibility before patient treatment. Hip Dysplasia Pro App indicated for assisting healthcare professionals. Clinical judgment and experience are required to properly use the software. Data from load and pressure distribution in the hip, like in a real biomechanical tests, are being measured and depicted graphically as vectors over the X-ray and the screen over the joint. The distribution also of compressive stresses over the acetabulum, which is usually associated radiographic sclerosis over the acetabular margin, are printed in real time over the screen and thus can be easily and objectively evaluated. Besides that, the app provides data in export for diagrams of load, R, pressure, P, which each can be plotted as a curve, allowing easy comparison with normal data and thus help decide the orthopedic surgeon which procedure is objectively indicated. Data are exported as TXT file, ready to print or to input as cells to numbers or Excel ready for chart printing and further research. The app covers a standard pelvic X-ray from a simple image into an accurate biomechanical analysis study, involving a calculation of the joint load and pressure. In clinical settings, easily assessments of hip load and pressure may help planning operations, modify or monitor objectively treatment strategies in an effort to improve hip biomechanics.